Here's a graph of a function. And I would like you to choose from here whatever you would like us to do. These are all similar transformations with what we just looked at in the last one, right? So especially this one, right? 1/2 f of twice x, and this one too, f of 1/2 x. These are exactly what we just discussed, 49 and 50. Which one? 50. 50 it is. I have to copy this graph. It's very simple. It's going to take a second to copy it. I'll give it a point. So this is problem 50 on page 295. So let's copy it. So we have a -4 and -2. -4, -2. We have this point, which is -2. We have this point, which is 2, 0. We have this point, which is 2, 2. And we have this point, which is 4, 0. Here's the graph. And 50 is asking us to determine, so this is the graph of g of x. So they want us to determine g of x, which is, this is f of x, sorry. And they want us to determine a new function, which is g of x, which is 1/2 f of twice x. Notice one thing, that I was not able to show you this transformation with any of the graphs. I can show you with the square root or with the absolute value. So you can understand it quickly. I mean, I can, and we can use this for any function, but it's basically and mainly used for trig functions, to tell you the truth, this particular transformation. But we are not looking at trig functions here. But we can use any function. Okay, ready? Which is the first transformation we have to perform on f of x? Yes, f of twice x. Which is the second transformation that will be performed on function from 1? 1/2 f of twice x. Excellent. Good. So what does this mean? What am I supposed to do when I graph f of twice x? Remember, it's the opposite of what you would expect every time you change x into twice x or x into 1/2 x or 1/3 x or 1/4 x.
Horizontal shrinking.
Horizontal shrinking of by a factor of not of 2. Of course, that's not going to be shrinking by a factor of 1/2. This point is over -4. I divide -4 by 2. It will move here. This point has x equals -2. I divide -2 by 2. Where does it go? At -2 divided by 2 is not 0, but is -1. This point has x equals 0. Divide the 0 by 2. Good. This point has x equals 2. Divide the 2 by 2. This point has x equals 4. Divide its x by 2. Here is the graph. This is the graph of f of twice x. Now I need to multiply each height. Each y value gets multiplied. Normally, there is no twist here, by 1/2. This height is -2. I have to multiply it by 2, by 1/2. Where does it go? Yes. So the height is -2. I divide it by 2. It moves to, this point moves to -1. This point has a height of 0. Where does it go? 0 divided by 2 is still 0. Yes. This point has a height of 2. divide its height by 2. Perfect. This point has a height of 2. Divide its height by 2. And this point has a height of 0. Divide its height by 2. This is final, which is 1/2 f of twice x. Questions? Questions? Okay, the next topic is something that you, I'm sure, remember at least part of it. It's 2.6. I like to call it algebra of functions. Not combinations of functions, but that's good too. TK, go ahead. Any questions? Algebra of functions and function composition. We've seen this, I'm sure, in other courses. We are given functions f and function g. We have two functions, and we want to create their sum. We want to create their difference. We want to create their product, and we want to create their ratio. That's how functions get created. And there is one more. There is a fifth way, but let's discuss these 4 ways first. So if somebody gives you 2 functions, can you add them and create a new one? Yes, you can. Of course. Can you subtract them and create a new function? Yes. Can you multiply, etc., etc.? So please give me 2 functions so we can illustrate this. However, there is a restriction that I will talk about in a minute. But just give me 2 functions. Okay. I'm going to say x squared minus 3x and negative 2x squared minus 4. Can anyone give us the definition of this function? Not for any particular example, but what do you think this should be? Should equal to? F of? Indeed, plus? That's it. This is f of x minus g of x. This is f of x times g of x. And this is f of x over g of x. For the previous 3, I did not write this, but in this case, I have to write if. What does that if mean? If what? Why? Correct. Very good. We cannot divide by 0, so division by 0 is, we know it's undefined, so we cannot have g of x being 0. Okay, before we use these functions to create these 4 functions, I would like us to look at the following scenario. Let's suppose I have a function that is this, and I have a function, this is f of x, and let's suppose I have a function that is this, and that's my g of x, and this is 10, this is 2, this is negative 4. Can anyone give us the domain of function f?
Negative 4 to 10.
Very good. F is negative 4 to 2, right? And the domain of G? Very good. We all agree with that. And let's suppose I ask you now to find f plus g of 3. You will say that's easy. It's f of 3 plus g of 3. Same thing, it's just adding f of 3 to g of 3. But then you will also say, wait a minute. Why would you say, wait a minute?
Because they overlap.
No. If they don't overlap, there is a problem. So what is the problem here?
One,
Shall one be negative and positive?
they have inverted slopes.
Of course, f of 3 does not exist. 3 is here.
Yeah.
The function f does not exist at 3. So you cannot determine this. It doesn't exist. Say it again. Right. So then, if these two functions do not have a, so f of x and g of x must have a in order to create sum, difference, product, and ratio. What do they have to have? Say it again.
Let's see.
Shared.
Very good. Common. If they do not have a common domain, if you cannot evaluate both for the same value, you cannot create the sum, the difference, product, and ratio. They don't exist. So what is the common domain of f and g? CD. Common domain is 0 to 2. So if I want you to create these functions for me, I have to tell you find f over g at 1. Find f over g at 1.3. Find f over g at 0.3. But I cannot ask you to find f over g at -3 because g does not exist at -3. Okay. So I only have 1 minute left, so I'm just going to show the sum, and then we'll determine the rest next time. So for the sum, I know it's a lot of writing in this section, but it's really nothing. It's just copying. So I'm copying x squared minus 3x. I'm copying negative 2x squared minus 4, and perform the operations. X squared minus 3x minus 2x squared minus 4. I get negative x squared minus 3x minus 4, which is final. And that is the sum of those two functions.